In this video, we're going to discuss circular measure with radians. So circular measure like areas of sectors, area of segments, arc length, chord length. So arc length and area of a sector we can do using degrees, just using the angle divided by 360 times the area or the circumference formula. However, there are other formulas that are used when we're looking at radians. So we've got our arc length first, and I've drawn a circle here with A and B on it, and I'm just going to draw for you the minor arc length, which is the green, and then the major arc would be obviously the other side. The arc length is found by doing the radius multiplied by the angle in radians. So for these ones, it's not so important about your calculator being in radians, but anything that has the sine function in it, you need to make sure that if you're using a calculator to do these, that your calculator is set into radians, not degrees. So an example for calculating the length of the minor arc AB. So we're looking at the minor arc here. So it's this one where we've got our internal angle is pi on 5 and our radius there is 4 centimeters. So if we have a look at our formula, it was radius times the angle in radians. So we would do the length is equal to the radius times the angle in radians. So that would give us 4 pi on 5 centimeters if we were leaving it in exact values. Otherwise, we would type that into our calculator and we would get an arc length of 2.5, 1 centimeters to 2 decimal places. If we then look at that same circle and we find the length of the major arc AB, so we're looking at the major arc this time, we obviously need the other angle. So to find the other angle first, so to get the angle, we actually need to do 2 pi take away pi on 5, because that's going to give us, remember 2 pi is 360 degrees. So if we do 2 pi take away pi on 5, and we're going to leave it as an exact value this time, just so for our calculation, we would get 9 pi on 5. And then to calculate our arc length, we would do 4 times 9 pi on 5. And again, we're not going to leave that in standard form. We're going to put it into a decimal form. We would get 22.62 centimetres as our major arc length, that green arc length there between A and B. Then we move on to sector area. So again, like I said at the start of the video, sector area usually is found by doing the angle divided by 360 times pi r squared. However, because we're working in radians this time, our sector area formula is actually half of the radius squared times the angle. Again, the angle is in radians. You can see the coloured in sector there would be the minor sector. The other portion of the circle there would be a major sector. So we've got an example here. Calculate the area of the minor sector AOB. We've got a radius of 6 centimetres and an angle there of pi on 3. Obviously, the diagrams are not drawn to scale. So our formula is half of the radius squared times the angle. Okay, again, if you're leaving it in exact values, you would just leave it in terms of pi. Otherwise, if we were using our calculator, you can round to 2 decimal places or whatever it's supposed to be rounded to. Okay, so if we did it in exact values, that would become 6 pi because it would be 18 pi on 3. But in actual formats, it is 18.85 centimetres squared for that. Obviously, if we were asked to find the major sector there, you would need to do 2 pi take pi on 3 again and get the other angle to work with it. And same formula, same process, but you just need that extra step. Then we've got chord length. So a chord is a line through a circle that doesn't go through the centre. So I'll just draw it on here, line AB there. our formula is 2 times the radius and then sine times half of the angle, sine of half of the angle. Again, the angle is in radians. So if we were to do this question, we would have the chord length is equal to 2 times 5, because the radius is 5, times sine of half of 2 pi on 3. Again, you could do this and leave it in exact values, but for the purpose of this video, I have used my calculator. Again, my calculator needs to be in radians, especially for this one because sine is involved. The answer comes out to be 8.66 centimetres. So the length of chord AB here, which is this line that I've just drawn there, is 8.66 centimetres. The last thing that we're going to cover is segment area. So a segment of a circle compared to a sector of a circle. A sector is cut through the centre of the circle, whereas a segment is chopped through it with a chord. So you can see chord AB has taken that minor segment there off the circle, which is coloured in, or we've got the major segment, which is the other side there. The formula for area of a segment is A equals half of the radius squared, and then we multiply that by the angle, take away sine of the angle. Again, the angle is in radians, so we need to make sure our calculator is set in radians. So we've got an example here, calculate the area of the minor segment. So we're talking about the minor segment here that I've coloured in there, as opposed to the major segment. We've got a radius of 6 and an angle of 2 pi on 3. So we'll have our area formula, you can see, is half times the radius squared times the angle, take away sine of the angle. And if we type that into our calculator again, we end up with an area of 22.11 centimetres squared. The same thing applies if we were asked to find the major segment. We'd need to change the angle that we're looking at, but most of the time you could use the minor segment. The other alternative to having to use the segment formula is you could calculate the area of the sector that you can see here. If I put on here, we could do the sector of OA and B. And then we could also calculate, if we had enough information, which we do, we could calculate the area of triangle AOB using half AB sine C, and we could subtract the two to then find the area of the segment. Obviously, that's just a bit of the longer way to do it, but it's a way you can do it if you don't have the segment area formula with you. And that is everything there is to know about circular measure with radians.